Hello and good afternoon, good evening, everyone. This is Shreya Pohekar, and I am Null Bhopal chapter lead. And I hope that you all are safe in your homes. And yes, today I'll be the host for your session. And if you don't know about what exactly is Null, so let me brief a bit about you. So, Null is the open community for security. It's a place for like minded people to come together and share their thoughts and share anything they have relating to security. So, who are we? We are one of the most active, we are amongst the most active community in security, and we have across 15 chapters running all over the India, and two of them that run abroad, and they are Amsterdam and the Dubai chapters. So who we have in Null? Basically, we have like everyone from any kind of field that is related to security, but also we have people like who are like hardcore developers into the community who are willing to learn more about or get deep dive into the security. So we have penetration testers, a lot of students who are interested in these fields, and security professionals. What do we do? We eat, sleep, hack, and repeat. Okay, so apart from hack, you can like add anything you want or anything you do. But yeah, the hacking is something that we do every day. So
Um, I think Shreya Didi just went away from the screen. Um, Let me check. Sir, I think you can start now.
Okay, so I'll try to share my screen. Maybe I may
Uh,
not be able to do that. Let me try. Let me give it a shot.
yeah, you can maybe
Pulia
share
session
your
we have.
screen now.
Okay, so I went offline. Wait.
Let Swapneel sir share the screen now, sir. We can maybe do it in between or later, or
So you,
go on.
you can proceed and then maybe I can start. You can probably start from wherever
Yeah,
you have stopped. I
let,
think it was
yeah,
a slide. Hack, hack, eat, hack, and sleep. I don't know which one.
yeah.
Hey, am I audible now?
Yes, you are audible, and we can see
Okay,
your screen.
cool.
Go on.
So, so what we have in Null is monthly meetups, Bachao sessions, Hamla sessions, Palya sessions. So I will explain it in a brief that monthly meetups are what we are having right now. That's where a speaker comes in to present a topic for 1 hour or so. In Hamla session, we have something like we attack the machines. It's kind of offensive security that we have. Then we have the Palya session where we bridge the gap between all the community members because we have a wide diversity of people in there, like students to security professionals. So ensure that we all are on the same page, we organize sessions like Pulia sessions and then the Bachao session. That's where we defend our machines. So that's exactly opposite to the Hamla, where we are having offensive security. In this, we have the defensive security. So that's the team Null Bhopal. These are all the chapter leads from Null. So what's in there for you? Actually, apart from all these 4 points that are written here, there's a lot more thing you get when you join in a community. So obviously you learn, you get exposure to security industry, you increase your network because it's like Null Bhopal, but you get to connect with members of all the Null chapters, and you increase your network to a whole new level. And yes, you get your name out there, and that's happened when you come up and speak, so people get to recognize you. Okay, so how you can become a part of Null? You can join Null mailing list. Then you can attend meetups and workshops and network with people who are there in the meetups. As of now, we are having virtual, but yes, after this corona goes off, we'll be obviously having the offline meets. Then you can register yourself on null.co.in, where you can RSVP for every meet, and that will be creating your public profile. And yes, you can also become a volunteer, where you like find different people or different speakers who can present for the null meets or different sessions that I mentioned earlier. Okay. So for today, we are having Swapneel, and he'll be presenting upon DNS firewalls, using DNS as a layer of defense. So over to you, Swapneel, and all the very best for your session. And yeah, you
Thank you so
can
much.
share
I
screen
think
now.
I will go ahead and share my screen. Can you confirm the presentation is visible? Shreya?
Yeah, it's visible.
Can you confirm if the presentation is visible to you?
Swapneel, it's visible.
Okay, great. Thank you. All right. So
Okay.
welcome. Thanks for joining in. And I think I will quickly give introduction about me so that who is presenting and what's my background. So I'm a network engineer as well as a researcher. So I primarily work on my interests with regards to the internet per se is BGP and DNS as well as DNSSEC. And more specifically, I concentrate on Unix systems as well as security. I'm a technical trainer as well, so I regularly have been conducting workshops on these topics, not only in India but even in Asia Pacific region per se. So I'm a community trainer for APNIC, which is the regional internet registry, and I also run a company. I'm a managing director of Shrestha IT Technologies Private Limited. It's a company based out of Belgaum, and we primarily build and secure networks for micro, small, medium enterprises, as well as network operators in tier 2 and tier 3 cities. I think that's all about me. Just making sure before I proceed to connect the charger. Yes, I think we are good to go. All right. So key takeaways. So today I'm going to talk about using DNS as a layer of defense. So I'm using StreamYard for probably the first time. So I may not be able to see what kind of questions. Yes, I can see certain comments there. So at any point of time when I'm doing the presentation, at any point of time you have a question, feel free and put a question in the comment box. And what I will do is every now and then I'll just pause and make sure that I look into the questions there are and maybe answer them first before going to the next part of the presentation. So one of the things which is I'm probably presenting this in the third Null chapter. So I think I've done the same presentation for the Null Bangalore as well as Null Mumbai, and this is the third one. Of course, in each presentation I have made some incremental changes. So in case if you are attending this for the third time, I hope you'll stick around to and probably wait for the additional increments that I've done to the presentation. So key takeaways. Let's say, for example, you're running a network, and now that with COVID everybody is at home, so we are no longer in corporate networks for that matter, which have security in place, which have firewalls or intrusion detection systems and so on. So everybody is working from home. So the whole point of this presentation would probably focus towards that angle. But the same thing applies not only from a home network perspective, but it is also going to apply for any kind of network. So even a corporate network, the same principles would apply. So the key agenda for today is how do you add a layer of defense to your network, and in this case, your home network. Again, as I said, this is applicable for network operators as well. So if you're an internet service provider, this talk or the meat of the discussion today will also be helpful for you. Plus, you are running let's say you are part of an organization and you're running a small network, also called as a SOHO network. This would be applicable for you as well. So what are the primary attack vectors in a network, right? So we work with a lot of small, medium enterprises, and few attack vectors which exist in any kind of network is the kind of websites that staff, employees, or people part of the organization would access. And with the kind of access to the websites, there could be phishing URLs, there could be malware, etc. Again, the second element is email, primarily used for communication. But having said that, there could be potential malicious files which are being transferred to email as well. Then you have another potential issue, especially in a small network or a network of a small organization per se, where there is a lot of sharing of data which happens by sharing of folders. And that's where we have seen that ransomware is a very potent attack vector which exists. And finally is the USB storage devices, where people would copy data from one machine to the other, primarily from the convenience perspective or for carrying it back to access it from home, for that matter. So I'm going to define a very important concept here, and the concept is something called as a flat network. So you are at home right now, you're all working from home, or you're accessing this from home. So the kind of network that you have at home right now, or even the network that I have at home right now, is basically a flat network. So what do I mean by that? What I mean is a flat network is one where there is no segmentation of traffic between that is happening between devices in the network. So say, for example, I have 10 devices in the network. Each device can communicate with one another without any restrictions. So it's a kind of a broadcast network where there is no isolation of traffic between the devices. So your home network is one common example of this. So here is diagrammatic representation of what do I mean by a flat network. So there are a few laptops or computers. There is an access point and there is servers, say, for example. This is typical to what I'm running at home right now. And in this case, let's say, for example, there is a ransomware on PC1 that you see on the image. There is nothing preventing it from trying to contact PC2 or PC3 or the servers in this case, right? So the whole idea behind the design of a flat network is primarily convenience. So people can set up a network without any special equipment. Say, for example, there is no segmentation of traffic, and that means that security is not the priority to begin with. And propagation, because of this kind of I wouldn't call it as a loophole, but the design of a flat network, propagation of malicious traffic within the network between devices is something that spreads very rapidly. So examples of a flat network, your home network, SOHO networks for that matter, even small organizations, micro, small, medium enterprises, especially the micro enterprises running a network, is something where it is primarily a flat network. And now I'm going to probably add a few elements. What we have seen from serving micro, small, medium enterprises is there is a large-scale ignorance with respect to security best practices. So security hygiene is something that is missing in a very large way. So as an example, people would have antivirus on their machines, but the license would be expired. So the whole point of the antivirus goes away in that sense. Or we have seen people in micro enterprises where there would be an antivirus and it would have a valid license. But what would happen is once they connect a pen drive, to save time, the person operating the computer would click cancel whenever the antivirus pops up for scanning the pen drive, say, for example, again causing a security issue. Decentralized user management, so everybody is logging in as administrator, and the whole reason why that is required in number of places, what we have seen from experiences, is primarily where people need access to the ERP. So the ERP software does not work if you have not logged in as an administrator. And lack of IT processes to begin with. So this is something not commonly seen from a home network perspective, but this is very common for a micro, small, medium enterprises for that matter. Here is a screenshot image of a phishing email for that matter. Here is a phishing, example of a phishing URL, which is impersonating Microsoft Outlook. Now I'm going to come back to DNS. So I'll quickly go through the fundamentals of DNS. Now that I've given you a good idea about the problem space with regards to a flat network design, what we have currently in our homes, I'm going to talk quickly about the fundamentals of DNS. So DNS is something I'm assuming that all of you know, but and also something the way in which DNS works, say for example. But quickly I will go through it so that in case if somebody who is not acquainted with how DNS works will get an understanding and will be up to speed. So DNS stands for domain name system. So what is happening is in this specific image, if you see on the left-hand side, you have a computer which is asking for the IP address brainattic.in. So every device or every operating system has a piece of code running, inside it, embedded inside it, called as a stub resolver. So the stub resolver gets a request, which is what is IP address of brainattic.in, and the stub resolver will then send that request to something called as a recursive DNS server. Now this is something which is a lost, I would say a lost piece of technology, because a lot of people have outsourced DNS to the cloud DNS providers, and I'll get back to the explanation about that a bit later. But a recursive DNS resolver or a recursive DNS server, both are the same. The job of the recursive DNS server is primarily to take a domain name, check if it exists in its cache. If it does, then give the answer back. And if it doesn't, then go down the delegation chain and find the answer and give it back to the client machine which had asked for the question, which had asked the question. So in this case, when the client machine, let's say, for example, the user types brainattic.in in the browser, the request goes to the stub resolver. The stub resolver takes the request and sends it to the recursive DNS resolver. The recursive, let's assume for the sake for the sake of simplicity, that the recursive DNS resolver does not have the answer in its cache. Then what it will do is, since it is .in, it will contact the .in, or it will contact first the root servers. So there are 13 root servers in total, operated by 12 root server operators all around the world. But in ideally, it's not just 13 root servers. There are 1,086 instances of the root server running using a technology called as Anycast. So if I have to simplify, Anycast is basically announcing the same IP address at multiple locations. So the nearest instance would answer to based on the closest proximity of the user. So in this case, when brainattic request goes to recursive will contact the root servers asking for the question, hey, what is the IP address of brainattic.in? The root server says, hey, I don't know the answer of brainattic.in, but I know the servers which are responsible for .in. So the recursive server now contacts the .in servers asking for the same question again. Hey, what is the IP address of brainattic.in? The .in server says, hey, I'm not authoritative. I'm not the owner of brainattic.in, but I know which servers are authoritative or which servers are the owners for brainattic.in. So now the recursive resolver will contact the servers of brainattic.in and ask the same question again. Hey, what is the IP address of brainattic.in? And one of these servers will respond back with an answer saying that brainattic.in IP address is, let's say 1.2.3.4 for the sake of simplicity. The recursive resolver will then take the answer, keep it in its cache, and then send it back to the client device. I'm sorry, what you're seeing as a pop-up is basically a firewall. So the browser is making some connections, and that's the reason why it is asking for the pop-up. So I hope this is clear with regards to how DNS works and the functionality of a recursive DNS server or functionality of the recursive DNS resolver for that matter.
So Swapneel, can you please maximize your slides actually, because I am unable to see much of it.
Sure. How about now?
No, can you put it on full screen?
Done.
Yeah.
Does it look good now?
Yeah, it looks good.
Well, the reason I did it, I did not go full screen is because then I lose out on if somebody is asking for questions in the Q&A. But maybe I'll proceed this way.
Yeah, maybe you can take questions after a while.
Okay, I'll do that. All right. Okay, so I'm assuming that now with the fundamentals of DNS 101, you should have understood how DNS works fundamentally. And this is what is happening behind the scenes. So one of the things that you have to remember here is for you to kind of implement whatever I demonstrate today, as well as the concept, as well as the practical element of it, you need to run your own recursive DNS resolver in your network. So if you have outsourced DNS to say 8.8.8.8, this is not going to work. This is not going to be helpful for you. So I'm hopefully at the end of it, I may have, I'm hoping that I would have convinced you to run your own recursive resolver and utilize DNS as a layer of defense. Yeah, so as I said, a lot of people, a lot of network operators, a lot of ISPs. So there has been a shift of recursive DNS resolvers. So what do I mean by a shift of recursive DNS resolvers is, in the earlier days, people used to run a resolver, DNS resolver on their laptops or on their machines, right? And then it slowly shifted to the internet service providers. So the internet service providers started running them and used to give it as a service. There are still internet service providers who do that, but majority of the internet service providers have kind of outsourced it to cloud DNS servers, cloud DNS resolvers, or quad DNS resolvers like 8.8.8.8, which is by Google Public DNS, quad 9, which is 9.9.9.9, or Cloudflare, which is 1.1.1.1. By the way, Cloudflare had an outage yesterday. So if you're using Cloudflare 1.1.1.1, internet would have stopped working for you. And the reason I have a smile on my face is I have been a big proponent of making people to implement and run their own resolvers, because by outsourcing your DNS, you are outsourcing your entire internet DNS records or history to a company with which you have no contractual obligation. These are for-profit companies, except maybe Quad 9, but these are all international companies. These are not Indian companies to begin with. And what you are doing by using these as DNS services or DNS resolvers is all your DNS records that you access on your devices, be it computers, laptops, mobile phones, is all going to these companies for that matter. So I would urge you to run your own recursive resolvers, and the way you can do that is by using open source software. I'm a big proponent of open source, so I would urge you to explore Unbound. These are excellent piece of software which have been powering the internet for a very long time. The root server software, the root servers are also running software from some of these open source vendors. So I know the K-root server, which is run by the RIPE NCC, is using NSD, which is again from NLNet Labs, which is the same organization which is behind Unbound. Then you have Bind, which is from ISC, Power DNS, Nord DNS, and at last there is another project called as Pi-hole, which I'll talk at the very end. So how does a DNS firewall help? So the way a DNS firewall helps is everything on the internet, no matter what you do on the internet, it starts with a DNS query. Without DNS, internet does not work. So DNS is used for legitimate purposes by people like you and me who are accessing services, maybe a bank website, maybe your social networking website, or even when you are accessing this, you had to resolve the domain name when you are accessing the platform where the presentation is being given. And DNS is also abused by malware. The bad actors also use DNS primarily to, if there is a command and control bot, then the command and control bot, the element which is on the client device would try to connect to the command and control mothership. And when it is trying to do the connection, it's ideally going to be on a DNS layer. It's going to be a domain name. So by using something called as a DNS firewall, you can set a differentiated route. So you can basically say that legitimate queries will be answered, and if it is something which is known as bad, you would probably send it to a black hole, which is also called as an NX domain. And the most important part for a home network, in this case more specifically, it's a cheap defense in a flat network. You could take a simple device like a Raspberry Pi and configure it as a DNS firewall, and it's going to be the most economical solution that you can have. And if you want to only do this on a laptop, then you just use the open source software. Then you don't need to have a Raspberry Pi also. Having said that, I think I would like to also point out that security is a multi-tiered approach. It's a multi-layered approach. It's just not just by putting a DNS firewall means that you are secure. It's just one layer of defense. It does not entail the entire stack with regards to security for that matter. So DNS, this is the DNS firewalls is also DNS firewalls is also called as DNS RPZ. RPZ stands for Response Policy Zones. It's basically a vendor-neutral distributed format. There is currently an IETF internet draft. It is not a standard yet. The draft is by Dr. Paul Vixie and V. Shriver, and hopefully it will be a standard. But having said that, all open source DNS software, which I mentioned in my previous slide, like Unbound, Bind, Power DNS, and Not DNS as well, if I'm not mistaken, have support for response policy zones, complete support for response policy zones. So what it means is, it basically means that you can have a policy, just as in any firewall where you have a policy. In DNS firewall, you can also have a policy where you set a differentiated route for the bad stuff. And the most important part, which is again something which adds more value from a DNS firewall perspective, is you can integrate a DNS firewall with something called as threat intelligence data feeds. There are a lot of threat intelligence vendors who are providing feeds. When I say feeds, in general, it's data about, let's say, bad domains in this case, right? So known bad phishing domains or known bad domains used for malware. That's real-time data that these vendors provide. So you could integrate real-time threat intelligence data feeds into these open source software to have security at the network layer. So just like any other firewall, the way in which this works is you have a trigger and then you have an action. What it means is, once the trigger is met, there is a specific action. So let me give you an example here. There are various different possible combinations that can be used. But I'll probably take the first one as an example. QName stands for query name. What it means is, let's say if the query name is equal to abc.com, have the DNS firewall configured with this policy such that it responds with an NX domain. So if you see the number 2 in the action column, an NX domain means non-existent domain. What this means is, even though that the domain might actually be resolving on the internet, in your local DNS firewall, you are saying you have a policy in place which says abc.com as an example. If any device in my network accesses a domain and abc.com, give a response NX domain, which means non-existent. Give a response back to the client device saying that this domain does not exist, even though in actual circumstances the domain name actually exists on the internet and is something that resolves. So using this, you can see you can have a powerful defense in your network where known malware, known domains. In fact, I have been using DNS firewalls for quite a good amount of time. I even block ads for that matter. So I primarily have a feed which is integrated into my DNS firewall, which runs in my network. And what it does is, it has a list of all the known domains which are used for profiling for ads, etc. So any device in my home network, any mobile device, my family, anyone who is accessing anything on the internet, assuming a request goes to a domain which is part of that zone file or part of that data, will get NX domain, which means it will not load on the device at all. So what this means is, it primarily gives a good layer of not only security, it also gives a good layer of privacy from a profiling perspective, where there might be a lot of companies who are trying to profile and gather data based on what kind of content that you're accessing. Here is an example of a DNS zone file. So in case if you have never worked on DNS, don't worry about the format of the DNS zone file. So what it means is, I'll go to the very bottom of the file. These are basically something called as DNS records, which basically specify what should happen, or what does a domain name resolve to. So as an example, if you see at the very bottom, we are saying staging.instaping.in, which means address record, should resolve to the IP address 203.192.220.112. Similarly, webmail.instaping.in, the domain name is instaping.in. Webmail.instaping.in is going to resolve to 106.201.125.76. So this is a zone file which will typically, you will find it on an authoritative name server. So I gave the earlier example of DNS fundamentals. where I talked about those 4 servers at the bottom. So if I quickly go back and show you, so in the pictorial diagrammatic representation that you are seeing here, at the very bottom of it, you see ns1.eth1.in, ns2.eth1.in, and so on. These are the authoritative name servers for brainattic.in, for which the question was asked. So you would find the zone file typically on an authoritative server. So this is a format of a zone file, typical zone file. And here is an example of a DNS response policy zone file. So if you see this example, ignore the content which is having a semicolon. That's basically comments. The first entry that you see there, which is adservice.google.com.vn. Now this is basically a domain name which is provided by Stephen Black. Stephen Black is a good friend who runs. If you have heard about the host file, he runs a very popular project called as the host file. And sometime back, I convinced their developers to actually also provide a response policy zone using the host file. So they graciously, actually took that request, and we have a response policy zone which is available free of cost for anyone to load. So this is something that I run in my network. So if you see adservice.google.com.vn, that's a domain name. Cname dot, what it means is this is the policy that I have in my zone file, which means any user in my network, if it tries any device in the network, if it tries to resolve adservice.google.com.vn, respond with an answer NX domain, which means tell them that this domain does not exist, even though on the internet this exists. So I hope you got an understanding of how this works. On your recursive DNS software, whatever the recursive DNS resolver that you're using, be it Unbound, be it Bind, be it Power DNS, this is how you would specify the zone file. This is a common syntax when you're specifying the zone file. And this is the part where you specify that this is a response policy zone. So this is what tells the software that this is to be considered as a response policy zone. And maybe I'll probably quickly show you a demo. Before I do that, let me see if there are any questions. I don't see any questions at this point of time. So probably I'm going to go to the demo part. So I hope you are able to see my terminal screen. If you cannot, please let me know. So what I've done here is I've just logged in into a virtual private server that I'm running. And I'll just go to the Unbound configuration that I run. And under that, what I have is something called as zone files. So let me give you an example. So Stephen Black is a zone file which I mentioned earlier. Let me probably show you the content of the file, or let me do a right. So if you see this, this is the zone file which you have this available on the internet for free. If you just probably search for Stephen Black response policy zone or RPZ, you should find the reference. Probably in my slides, which I've already uploaded on the Null chapter website, you will also have a reference link to it. So what we are doing here is we are saying, so here is a compiled list of domain names which are basically adware or malware. So here is an example of a domain name which is basically adware. So let me take this domain, and if I say dig@127.0.0.1, and if I try to resolve it, you see that the answer is NX domain, which means my local resolver running on this machine basically responded saying that domain does not exist. Having said that, if I do the same thing with something like 8.8.8, right now it is showing that it doesn't resolve as well because maybe the domain was taken down. Maybe let me take another example. I know this domain name for as a matter of knowing that this is primarily used for tracking of ads.
Actually, we can see your screen, but your font is so small that it's not really visible all that much. Can you please increase it a bit? Yeah, go. Yeah, this is fine. This is fine.
Great.
Thank you.
So let me run this. Thanks for pointing that out. Sometimes perils of presenting remotely. So I'm used to doing these hands-on workshops where I have a real feel of people sitting in front and asking questions and stuff like that. So doing this virtually is always challenging. So my apologies if this was not.
No problem.
Yeah, so I'll probably backtrack a bit for a minute and run through this example again, so that people who may not have seen this visibly, you should be able to probably follow on. So what I've done is, if I have to show you the example again, what I'm doing is I'm logging into my a VPS that I run, nothing but a virtual private server that I run, and I have configured Unbound there. Inside of Unbound, what I have is basically Stephen Black zone file, which I talked about earlier. So if I show you the format of this, you can see that it is containing a list of domains and having a policy which says CNAME stands for canonical name. I'm sorry, canonical name, and dot means give an NX domain as an answer. So what I'm going to do is I'm going to use a domain which I know, which is also present in this specific zone file. So doubleclick.net is one of the domains which is primarily used by ad companies to begin with. If I'm not mistaken, I think Google itself runs it. So if I do dig @127.0.0.1 doubleclick.net. By the way, 127. When I say so dig is, let me backtrack a bit. Dig is basically a command line tool which tells you, which you can use to find out whether if you give it a domain name, it tells you whether the domain resolves or not, and if it resolves, what is the answer that it gives back. When I say dig @127.0.0.1, what I'm saying is send this DNS request to Unbound, which is running locally, right? And the domain name is doubleclick.net. When you do that, you see the answer is NX domain. Having said that, if I do something like 8.8.8.8 and I send this, I'm sorry, not NX domain, doubleclick.net. So if I send the request to Quad DNS resolver, you see that it resolves, right? So you can now probably, hopefully, you can get an understanding that at the DNS layer, I am blocking domain names which are adware, malware, any kind of domain name for that matter. I have done one more additional thing as well, and again using DNS Response Policy Zones. I have a daughter. She's going to turn 5 years next month, and because education has all gone online, like it or not, access to YouTube has increased tenfold. So one of the things which I wanted to ideally do is to make sure was probably give a safe search option with regards to whenever she's accessing YouTube on her mobile device. When I say her device, it's my device, but when I'm giving it to her, it's hers, because she doesn't give it back to me. Okay, jokes apart. So I wanted to basically configure a setting in which whatever she sees inside YouTube is basically safe search, which means that Google provides an option. I don't know whether you know this, but Google provides an option that whenever, if you would like, you can use the safe search option so that whatever is being searched inside YouTube will be safe, right? And that's very important, especially in that context. So you could even do that using DNS Response Policy Zones. So I have a link on my slides, references, under references. So you could even look into that if that interests you, if you have small children at home, or you would like to kind of give a safe option for people who are accessing. Okay, let me go back to the demo. So reputation feeds, as I said, I hope I have good amount of time. Shreya and I'm sorry, I didn't catch your name.
Yeah, you can carry on. You have a lot of time. Don't worry on that.
In case if I'm going overboard, please shout out, because otherwise I can speak for the entire evening. Having said that, reputation feeds. So there are a lot of vendors which provide reputation data, reputation feeds. And when I say, again, as a simple explanation of what is meant by reputation feed, these are basically vendors or community efforts which basically have data with regards to domain names which are malware, which are phishing, which are used by command and control bots, and so on. So URL House is one of the organizations. It's a community-based organization which provides a free DNS Response Policy Zone feed. So if you're interested, you can look into that. Serbal is another company. Spam House Technology is another. Farsight Security is another. Switch is another. vendor. So the last four which I've mentioned are basically are basically vendors which provide feeds at a commercial fee. Having said that, Spamhaus technology also provides a free feed, and irrespective of that, you can also create your own feed. So one of the lessons learned with regards to doing this for maybe 200 odd networks at scale is there is a chance of false positives. So there might be a possibility that you might put a domain name in one of the zone files and have a policy to block it, which might be a legitimate domain. So it's very important that you understand that what data that you feed into your DNS firewall is basically something that you are kind of vetting it out as a process. Second thing which I will recommend if you are going to do this from an enterprise perspective or from a small organization perspective, this is monitoring analysis is definitely a must. So log file is your friend. That is something, looking at the log file will give you an understanding of what is happening behind the scenes. And you could always, we have integrated this with something called as the ELK stack, which allows for real-time analysis to do this. So the Spamhaus DNS Response Policy Zone is basically free feed. So they provide 3 feeds that you can look into. One is do not route or peer. It's called as a drop feed. Then there is a coin blocker. So crypto hijackers, for that matter, or the crypto malware which is there on the internet, there is a feed for that, and Tor blocker as well. So people using Tor primarily from purposes which is malware is something that you can explore. So the whole gist of the entire DNS firewalls is to identify and stop unwanted outbound abuse. And especially this is getting more challenging with the kind of IoT devices that you have, and you don't know what kind of connections that they typically make outbound. So DNS firewall is definitely helpful in that case. So one of the first things what I would urge you to do, and hopefully with this presentation you have got a fair bit of ideas, is to run your own recursive resolver. So I run a recursive resolver on my laptop as well. I run a recursive resolver on one of the servers which I just logged in and I showed you, because when I used to travel, and I used to travel is now probably going to happen. I'm going to say this for a very long time. When I used to travel, I used to use that as my DNS resolver. And that server is configured with response policy zones. So even when I'm traveling, my all kind of adware, malware is getting blocked at the DNS layer, and that is something that is super useful. So run any kind of open source software. So you can choose from bind, unbound, power DNS, whatever works for you. Here is another interesting project which I would probably also urge you to look into. Of course, this is not DNS Response Policy Zone. It doesn't utilize DNS Response Policy Zone. The project is called as Pi-hole. So the Pi-hole is basically a project which is nothing but a DNS server, DNS resolver, and it uses an open source DNS resolver software called as DNS Mask behind the scenes. But what it does is it provides a nice UI which you can configure, and you can see how many requests have happened, how many requests have been blocked, and so on. I'm sorry. One of the key features that they added quite recently, I think a month or so ago, I think in version 5.0 onwards, is the element to kind of selectively allow and block. So earlier, the way Pi-hole used to work was, if you block a domain, it used to be blocked for the entire network. Now, in the version 5.0, they have added a feature where you can selectively allow and block depending on the device. So that's pretty useful. So if DNS Response Policy Zone seems too intimidating, or at certain places, for family and friends, what I've done is I've installed the Pi-hole, and I've installed, I've actually connected a Raspberry Pi, in their network, and blocked all ads and malware and the Stephen Black host file and a bunch of other feeds as well. Challenges. So this is
Swapneel, are you there? I think his internet stopped working.
Yes.
This is something that.
Okay, he's back.
So,
Swapneel, your internet dropped for a minute, and we couldn't hear what you were saying. Actually, I
So
also
you
had a
can
question.
start from current challenges.
Yeah. Actually, I did not speak anything at all. What happened was my firewall basically popped up a connection the browser was making. So I kind of went from full screen and so I didn't, nobody missed out anything. But anyways, current challenges.
Actually, I have a question, sir.
Yeah.
So I have used pfSense and Pi-hole both to make a sort of in-between router and to impose Stevens blacklist or these DNS firewalls, DNS blacklist. When my outbound connections are going outside the network, Pi-hole or pfSense would stop it. But is there a way to do it in the software itself, like on my computer itself? Can I make something like that on my computer itself without having to add another thing to my router?
Absolutely. See, when I used to travel, one of the things which I still have on my MacBook is I run Unbound. Okay. So I run Unbound, which is a recursive DNS resolver. It's an open source DNS resolver software, and you can configure Unbound with DNS Response Policy Zones and add those zones, that data, whatever your blacklist data, right? You can configure it inside Unbound itself. So what it does is, whenever your machine, whenever in your operating system, any kind of DNS resolution is happening, the request would first go to Unbound. If the domain is allowed, it would find the answer by going down the delegation chain, and the domain would resolve. If you have blocked it inside the block list or the response policy zone file, then it would get blocked within the next domain. That is exactly what I do on my laptop as well.
Okay.
So I hope that answers your question. So you don't need.
Yeah, that.
But the problem is, you cannot apply this approach for an IoT device. You cannot do it for if you have 10, 15 devices in a network, and that has become the norm since COVID. You would like to get that protection for each and every device in your network, right? So
on my phone, I use this thing, DNS 66. There's this application called DNS 66. I use that to block all these lists. So you can do it on your device as well. It acts as a VPN. So whenever the connection goes through that app and it sees there is a rule for that sort of domain, it just drops it. So
I have a different view in terms of the latter comment that you. So I am not aware of DNS 66, so I cannot comment on it. But for people who are listening to this, please understand that whenever you use something which is not in your control, you are basically outsourcing your DNS in this case, right? So in comparison to that, what I would urge you to do is, or look into is, just as I demonstrated, I run a VPS, tiny little VPS on DigitalOcean, right? Maybe $5 per month. Okay. Maybe there are other providers which have a much more economical cost attached to it. Irrespective of what provider it is, I run a VPS which is configured with Unbound or Bind, has DNS response policy zone in it. So all the zone files which I'm blocking in my network here are also loaded there. Okay, and I use WireGuard.
Okay.
I don't know if you have heard about WireGuard. WireGuard is basically an open source VPN software which is the new kid in the block. It's much more.
Is it something like Glasswire?
No, it's a complete alternative to OpenVPN. So WireGuard has been ported into the Linux kernel. It has been ported into FreeBSD. It has also been ported into OpenBSD, and I think OpenBSD 6.8 is also going to have it. So what it does is it's basically a point-to-point connection, completely encrypted. So I kind of tunnel my DNS traffic via WireGuard to the VPS. The VPS running Unbound, doing response policy zones, blocks whatever is supposed to block. For whatever is not supposed to be blocked, it will recursively find the answer and give it back via the tunnel. Right. This is something which is much better option in my opinion, because you have control over your DNS traffic without even outsourcing it to somebody else for that matter. Okay. So any other questions?
Yeah, yeah. So have you tried running RPI hole in Docker and especially over hotel Wi-Fi connections?
Just to clarify, you're talking about the Raspberry Pi, right? The Pi hole inside
Yes.
Docker. Is that what your
Yes,
question?
yes.
Yeah. So that's an interesting question because see, here is the important point. So when you're talking about hotel network, say for example, right? What they will ideally do is they will hijack your most of the places what I've seen is they will also do a lot of hijacking where they'll have a captive portal in place, right? And the way in which they will ask the users to go to the captive portal is by using something like DNS. So they will take your DNS traffic, redirect it to the captive portal page. So there is absolutely a possibility of I've not done it, but I run the Pi-hole software inside a container in a number of places. But it depends subjectively on the network. If the network is taking all DNS traffic which is originating from its network and redirecting it somewhere else, then you are going to lose out on your DNS for that matter. But having said that, the WireGuard alternative, the WireGuard option will work. That will be a very good alternative to have for people who are road warriors, people who are constantly traveling like me and as well as others who might be traveling and might be using a hotel network or a cafe network for that matter. So I hope that answers the question.
Yes, sir, it does.
Yes, sir.
Okay. By the way, please do not refer to me as sir. Please, although I have a few white hair, but I think that's the pedal of working in network security. Having said that, I'm probably having my younger days, kind of living my younger days with regards to working from home at this point of time. So current challenges, DOH. DOH is basically, if you do not know about this, DOH is DNS over HTTPS. So RFC is 8484. So if you're a RFC geek, I would probably assume that you've already read it. But if you have not, you should probably look into it. So what happens in the case of DOH is basically DNS requests which are originating from your machine will be sent via HTTPS. So, and at this point of time, Mozilla Firefox has support for DOH. And by default, Mozilla Firefox in the United States at this point, since a few months, has enabled it. It's basically it's not an opt-in; it's basically an opt-out, which means that it is enabled by default. People have to opt out of it. And what it means is anyone in the United States accessing internet on Mozilla Firefox, the DNS requests go to either Cloudflare or NextDNS. I think Comcast is the third DOH trusted recursive resolver that they have added. So I think these are the three. They have a program called Trusted Recursive Resolvers. So you and me cannot be part of it unless and until there is a vetting process that they have, which they will then have an option for people to choose. Google Chrome basically has announced that it is going to be opt-in, which means that it is not going to be enabled by default. Brave is again based on, that is something that I use, and is based on Chromium, is again opt-in, so it won't upgrade to DOH unless and until the OS is using a resolver which supports DOH. So why this is from a security context, this is a concern, is because we know about browsers, right? Browsers is basically, as a software, is a trusted piece of software that we are installing. Now, from a security point of view, I just want you probably think about it. What if now malware starts using DOH? What if malware, there is a command and control bot which comes in my home network, maybe somebody downloads something, and now if it has to connect to its mothership, instead of using DO53, which is DNS over traditional 53, it uses DOH, which means traffic is encrypted, which means my recursive resolver is not going to see the request at all. So the concern is these DNS requests will now get bypassed, and I will not have the necessary blocking that I have done in my network from a security perspective. From a as a user perspective, to answer your earlier question with regards to being in a hotel network or being in a cafe network, DOH probably adds encryption. Not probably, it adds encryption, but I think it's a great thing with regards to for a user to get encryption on the go. But it also has in my opinion, also has a downside with regards to security, because now malware is also going to use DOH to communicate with command and control.
So
Windows 10,
I have another question. Sorry. So
please.
my question is that when I was using this pfSense with Squid proxy in it, so what it does is it man the middles your traffic through when it goes from your laptop before going to the router, it goes into that, and Squid proxy looks for keywords and DNS requests and then blocks it over there. But it adds latency because the Squid proxy have to look everything inside the request, and it also isn't very secure in like a network of a company where I shouldn't be seeing all the traffic that people are going to. In that case, DOH won't work, right? Or will
Actually,
it?
so currently at this point of time, TLS 1.3 is currently being is in the works in the IETF. So IETF is Internet Engineering Task Force, which basically is the non-profit organization which looks into the internet standards per se. So TLS 1.3 is coming down the line. It's going to happen, and when TLS 1.3 comes, so at this point of time, the SNI, the domain name is still visible. So here is a catch and mouse situation at this point of time. In the case of a user, when they are using DOH, they still have to make a DNS request to basically connect to the DOH resolver. So the DOH resolver cannot be at this, and running a DOH resolver endpoint on an IP address is very hard. So let's say a DOH resolver running on a domain name, the domain name resolution first has to happen. In the case of TLS 1.3, you won't be able to see this traffic. You won't be able to have a proxy in between and cause all kinds of problems because it is part of HTTPS traffic. So it's going to be much harder. You're going to break everything for the user. So it's not going to be as simple as putting a Squid proxy and
inside, yeah.
being able to do a MITM, man in the middle, and probably then based on that filter and then allow. You won't be able to do that. So that's the biggest challenge that lies ahead from a security perspective. Having said that, I'm all for DOH. It definitely brings a lot of benefit to it. But then again, I have another view. Then what has also happened at this point of time? There is a lot of centralization that is happening with respect to DNS. So if you see right now in Mozilla Firefox, you can only choose from the 3 DOH providers which Mozilla decides at this point of time, and that's something that is challenging for maybe an internet service provider or for somebody like me who wants to run a DOH resolver. Okay. Windows 10 is also going to be opt-in. So Microsoft has announced support for DOH inside Windows 10 as well. I think they rolled out initial implementation for the insider channel. Apple, a couple of weeks ago, has announced support for DOH in iOS 14 as well as macOS 11. And it's going to be interesting to see how this works on those platforms as well. So here are the references with regards to whatever I have discussed today. So you have any questions or other, if you would like to go back to a few things which I have talked about here, you can go to the references which have been pointed out. I also gave a talk at RFCs We Love on DOH. So if you're interested to know about the workings of DOH, you can look into that. So there is a link for that as well. And I also wrote about DNS Response Policy Zones. Part 1 of it, part 2 is still in the works. So if you're more of a person who loves to read, you could look at the link which is on number 5 mentioned there. Any questions? Anything that I can answer at this point of time? Let me see the comments if there are any. I don't see any.
So, hey Swapneel, it was very, very informative session for me personally, and it was a pleasure to have you today. And thank you for coming up for this session, and it was really very great. And I want to thank you everyone who joined in for the session today. And if you got any doubts for these regarding the sessions, you can directly reach out at its yeah,
I have added the Twitter handle in the post of Null Bhopal itself, and it's on your screen also. So you can
you can directly reach out to him on the Twitter. And yeah, that's all for this session. And we'll all see you in the next one. And goodbye until then. Thank you.
Goodbye. Thank you.
Stay safe. Thank you.